Hey guys, how's it going? This is your boy Ismael coming back to you with another Try Hack Me challenge. And on today's video, I'm working on Burp Sweep Repeater. Learn how to use Repeater to duplicate requests in Burp Sweep is what we'll be working on. And first thing is we have to join this room. And we are joining now. So on this a project that I'm working on, there's a total of 9 tasks to do. So we'll get started on the first one. So welcome to the Burp Sweep Repeater room. In this room, we will explore the advanced capabilities of the Burp Sweep framework by focusing on the Burp Sweep Repeater module. Building upon foundational knowledge covered in Burp Sweep Basics room, we will delve into the powerful features of the repeater tool. You will learn how to manipulate and resend captured requests, and we will explore the various options and functionalities available in this exceptional module throughout the room. We will provide practical examples, including a real-world exercise to solidify your understanding of the concepts discussed. If you are new to Burp Sweep or have not completed the Burp Basics room, we recommend doing so before proceeding. The Burp Basic room establishes the fundamental knowledge necessary for this room and will enhance your learning experience. Deploy the virtual machine attached to this task by pressing the green Start Machine button. So as you can see, we already started it. Also, start the attack box by pressing the blue Start Attack Box button at the top of this room. If you are not using your own machine, then start Burp and follow along with the next task. So let's get this attack box going. Now we're gonna wait until this loads. So for the answer to the question below, it's just let's get started, no answer needed. And I'm gonna wait for this to the attack box to load up. So we moved on to task 2. What is repeater? Before using Burp Sweep Repeater, let's familiarize ourselves with its purpose and functionality. In essence, Burp Sweep Repeater enables us to modify and resend intercepted requests to a target of our choosing. It allows us to take a request captured in the Burp proxy and manipulate them, sending them repeatedly as needed. Alternatively, we can manually create requests from scratch, similar to using a command line tool like curl. The ability to edit and resend requests multiple times makes Repeater invaluable for manual exploration and testing of endpoints. It provides a user-friendly graphical interface for crafting request payloads and offers various views of the response, including a rendering engine for graphical representation. The repeater interface consists of 6 main sections, as depicted in an annotated diagram below. And let's familiarize ourselves more with it. So it has 6, as you can see, and we'll be reading what each one of these actually is more down the tasks. So let's get to it. Furthermore, request list located at the top left of the tab, it displays the list of repeater requests. Multiple requests can be managed simultaneously, and each new request sent to repeater will appear here. So that's what it will repeat. Request control. Positioned directly beneath the request list These controls allow us to send a request, cancel a hanging request, and navigate through the request history. Request response view. Occupying the majority of the interface, this section displays the request and response views. We can edit the request in the request view and forward it, while corresponding response will be shown in the response view. Layout option, located at the top right of the request response view. These options enable us to customize the layout of the request and response views. The default setting is a side-by-side horizontal layout, but we can also choose a vertical layout or combine them in a separate tabs. Inspector. Positioned on the right hand side, the inspector allows us to analyze and modify requests in a more intuitive manner than using the raw editor. We will explore this feature in a later task. Number 6. Target. Situated above the inspector, the target field specifies the IP address or domain to which requests are sent. When requests are sent to repeater from other Burp Suite components, the field is automatically populated. Which section gives us a more intuitive control over a request, and that is the inspector. 9. In the conclusion, congratulations on completing the Burp Suite repeater room. By now, you should have a solid understanding of effectively utilizing repeater to edit, manipulate, and resend requests. Additionally, you should have gained insight into the numerous practical applications of this tool. In the next room of the module, we will explore the Burp Suite Intruder module. Intruder allows for automated and customizable attacks, making it a powerful tool for various security testing scenarios. Good luck with the next room and enjoying exploring the capabilities of Burp Suite Intruder. And the answer question below, it's a very simple one. I can use Burp Suite Repeater, and we have proved that we now have knowledge on that, so we're going to go ahead and click complete. Voila guys, congratulations, you have completed the room. So now I'll see you next video at the Burp Suite Intruder. Over. Now we're on task 8, Extra Mile Challenge. Extra Mile Challenge, this is designed to test your skills in a slightly more challenging real-world scenario. Utilizing Burp Suite Repeater, if you possess the expertise to independently perform a manual SQL injection, you can skip ahead to the final question and attempt this as a blind challenge. However, a detailed walkthrough will be provided below if you require guidance. Prerequisite knowledge. Before starting on this challenge, it is recommended that you familiarize yourself with the principles of SQL injection. If you haven't already, please consider exploring the SQL injection room dedicated to this topic. Although a comprehensive step-by-step guide will be provided, having a basic understanding of SQL injection principles will have proved beneficial in completing this task. Challenge objective. Your objective in this challenge is to identify and exploit a Union SQL injection vulnerability present in the ID parameter of the /about/ID endpoint. By leveraging this vulnerability, your task is to launch an attack to retrieve the notes about the CEO stored in the database. Walkthrough. We know that there is a vulnerability and we know where it is. Now we just need to exploit it. Now let's start by capturing requests to this link right here. So first of all, you have to have your interception off. So you will open the browser, then you'll copy paste this into the search engine. Boom. And here's the website that we are trying to hack right now. Now we're gonna put the interception back on. I'll hit reload. We'll retrieve the information from the website now. In the Burp proxy, once you have captured the request, send it to the repeater with the Control R or by right clicking and choosing Send to Repeater. Now that we have our requested primed, let's confirm that the vulnerability exists. Adding a single apostrophe is usually enough to cause the server to error when a simple SQL is present. So either using inspector or by editing the request path manually, add an apostrophe after the at the end of the path and send the request. So let's get started on that. We're gonna go ahead and send it, Control R, and let's delete this right here. So right here is what it's talking about. It's this to, and it wants us to add an apostrophe like it shows in the example. So I will add it. Now we're going to send. So we'll see the response now. And just like it wanted us, and we received 500 internal server error code. You should see that the server responds with a 500 internal server error, indicating that we successfully broke the query, and that is showing you exactly what we just got. If we look through the body of the server response, we see something very interesting around line 40. The server is telling us the query we tried to execute. This is extremely useful error message that the server should absolutely not be sending us. But the fact that we have it makes our job significantly more straightforward. The message tells us a couple of things that will be invaluable when exploiting this vulnerability. The data table we are selecting from is called people. The query selects 5 columns from the table: first name, last name, PFP link, role, and bio. We can guess where these fit into the page, which will be helpful for when we choose where to place our requests. With this information, we can skip over the query column number and table name. Enumeration steps. Although we have managed to cut out a lot of the enumeration required here, we still need to find the name of our target column. As we know the table name and number of rows, we can use union query to select the column name for the people. Table from the columns table in the information /gamma default database. A simple query for this is as follows. It's giving this query, and we're gonna have to type it in the request. Alright, so let's go ahead and get that out of the way. So I'm just gonna copy and paste this right here, and we will send it and see what happens. That's it. So we'll see the response. Alright, so we got it's needed. This creates a union query and selects our target. The for null column to avoid the query erroring out. Notice that we also changed the ID that we are selecting from 2 to 0. By setting the ID to an invalid number, we ensure that we don't retrieve anything with the original legitimate query. This means that the first row returned from the database will be our desired response from injected query. Looking through the return response, we can see that the first column name ID has been inserted into the page title. We have successfully pulled the first column name out of the ID, but we have not have a problem. The page is only displaying the first matching item. We need to see all of the matching items. Fortunately, we can use our SQL to group the results. We can still only retrieve one result at a time, but by using the group concat function, we can amalgamate all the columns names into a single output. So basically, now we have to insert this query, and we'll see what we get. Also, just to show you what we have right here, we have an ID none, which is pretty cool because that's what we got on the response. Oh, 1 second, sorry about that. ID none. So that's pretty nice. Anyways, let's get back to it. So it wants us to type in group column now, and we will do it like so. Group now we will send it. Now it's time to see the response. We have successfully identified 8 columns in the table ID. First name, last name, PF link, role, short role, bio, and notes. Considering our task, it seems a safe bet that our target column is notes. Finally, we are ready to take the flag from this database. We have all of the information that we need. The name of the people, the name of the target, notes. The ID of the CEO is 1. This can be found simply by clicking on Jameson's Wolf's profile on the /about/ page and checking the ID in the URL. Just one thing that I want to check out, see if this populated. Yeah, and it's the same thing. So it's exactly what you should get right there. So now going back to this query, let's craft a query to extract this flag. So now it's time to get the flag. So we'll go back into the request. I'm just going to go ahead and copy paste this into the request page. So we're going to go ahead and send it. Voila. And right here is the answer to your answer the question below. So exploit the Union SQL injection vulnerability in the site. What is the flag? Here you go, guys. You have the flag right there, so just go ahead and copy and paste that into the answer box and click correct answer. Furthermore, on task 7 challenge, in the previous task we've demonstrated the usage of repeater by adding a header and sending a request. This server as illustrative example for utilizing repeater. Now it's time for a straightforward challenge. To begin, making sure intercept is disabled in your proxy module and navigate to HTTP, your IP address access on the machine. Next, try clicking on some of the see more links. And let's get to it. So we're gonna open this up. I'm gonna copy paste this right here. Wrong one. Next, try clicking on some of the see more links. Alright, so we're gonna click on some. So we'll click this one right here. Observe that you are redirected to a numeric endpoint, and it's highlighting this specifically right here. So this is what your screen should look like. Right there. The objective is to validate the endpoint, confirming the existence of the number you wish to navigate to n and ensuring its valid integer. However, consider what might occur if this endpoint is not adequately validated. Answer the question below. So now getting to our first questions that we have to answer. The first one, enable intercept again and capture a request to one of the numeric products endpoints in the proxy module, then forward it to repeater. So let's go ahead and do that. Alright, so now we're going to go back to proxy, make sure it's on, and we'll click on this. So now there should be some action going on here. So now we're going to send it to the repeater. So now we have forwarded to the repeater. So this is done right here. Next question. See if you can get the server to error out with a 500 internal server error code by changing the number at the end of the request to extreme inputs. What is the flag you receive when you cause a 500 error in the endpoint? So we're just going to look at the hint because I believe it helps you out a lot. Question hint. The idea is to enter unexpected inputs to see how the server will react. For example, instead of a number, you could enter a piece of text or symbol. Alternatively, you could try entering a number greater than the number of products available, and it's giving you up to 1,000, or a number less than or equal to 0. So it's telling us we can use numbers, text, or symbols to cause a 500 error. So we'll just get started, and you are going to be so it's still the same thing. So the one that I just happened to click on was products, the /2 one. So we're going to change the number right here. We'll put 10 right there. Now we're going to forward it. Oh, I'm sorry, I was in the wrong one. Let's get on repeater. Sorry about that. So now we're going to send it. Now we're going to check out response. And now we only have a 404 not found error code. So ideally what we're looking for is 500 internal server error, which is not this. So the it wouldn't actually give us a flag. So now let's try changing this to 25. See if something happens. Check out response, and now we're still getting the 404 error code. Let's try 100. Oh Lord. Let's send it. Still nothing. So now let's try letters and symbols. Put these a money sign. Now let's send it. And we gotta check out. It's still giving us the 404 error code. So now let's just try a negative number. So we'll do -8 and send it. And boom, as you can see right here, we have a 500 internal server error code. So now let's scroll down and get our flag. Voila, here it is. Now you just copy and paste your flag, put it on here, and you should be good after that to move on to the next task. Furthermore, now we're on task 6, practical example. Repeater is particularly well suited for tasks requiring repetitive sending of similar requests, typically with minor modifications. This is particularly useful for activities such as manual testing for SQL injection vulnerabilities. To be covered in a forthcoming task, attempting to bypass web application firewalls, filters, or adjusting parameters in a form submission. Let's begin with an exceedingly simple example, utilizing repeater to modify the headers of a request sent to a target. Capture a request to HTTP at whatever your address is. That part you're going to put whatever your IP address is on your machine box uh, in the proxy module and send it to the repeater. So let's get that going. Let's get in the proxy. Turn this off. Open browser. We have to enable the sandbox. A quick copy and paste. Alright guys, so now we're just going to click on some of these and go back. So it actually has to be on for it to work. Give me a second. So now I'm going to go back to, we'll turn it on now so it could go ahead and capture the request. And we're going to go back on Burp Sweep, and we have this already. So now we're going to continue. Send the request once from repeater. You should see the HTML source code for the page you requested in the response view. Try viewing this one of the other displays options. Hex. So now let's go ahead and send it to repeater. It wants us to send. So we'll continue with this. Using inspector or manually if you prefer, add a header called flag authorized and set it to have a value of true as shown below. So I actually tried this earlier, and I noticed that if you're going to add it, it's better to add it in manually. So I'm just gonna go ahead and show you the manual way that which worked a lot better for me. So it's gonna be right here. So you're gonna click enter, then you're gonna click, oh not click, we're gonna just type in flag authorization, flag authorize, flag authorized. All right, then you're gonna set it to a value of true, and there you go, as shown below. So now you're gonna send it. Now you're gonna go to response, and here you go. It has the what you'll need down here. So on the answer question below, what is the flag you received? So it'd be this one. You just copy and paste it, and you're good to go. Task 5, Inspector. Inspector is a supplementary feature to requests and response views in the repeater module. It is used to obtain a visual organized breakdown of the request and response, as well as for experimenting to see how to change made using the higher level inspector affect the equivalent raw version. And as you could see, so this is what we were talking about on task 4, and now this is the inspector, what we are now talking about on task 5. Inspector can be utilized both in the proxy and repeater module. In both instances, it is situated on the far right side of the window, presenting a list of components with the request and response. Among these components, these sections pertaining to the request can typically be modified, enabling the addition, editing, and removing of items. For instance, in the request attributes section, we can alter elements related to the location, method, and protocol of the request. This includes modifying the desired resources to retrieve, changing the HTTP method from GET to another variant, or switching the protocol from HTTP/1 to HTTP/2. And right here is showing this examples that what it is talking about. Other sections available for viewing and or editing include 1. Request query parameters. These refer to data that's sent to the server via the URL. For example, in a GET request like https://admin tryhackme.com/?redirect equals false, the query parameter redirect has a value of false. Number 2, request body parameter. Similar to query parameters, but specific to POST requests. Any data sent as a part of a POST request will be displayed in this section, allowing us to modify the parameter before resending. Number 3, request cookies. This section contains a modifiable list of cookies sent with each request. Number 4, request headers. It enables us to view, access, and modify, including adding or removing any headers sent with our request. Editing. These headers can be valuable when examining how a web server responds to unexpected headers. Number 5, response headers. This section displays the header returned by the server in response to our request. It cannot be modified as well, as we have no control over the header returned by the server. Note that this section becomes visible only after sending and request and receiving a response. While the textual representation of these components can be found within the request and response views, Inspector tabular format provides a convenient way to visualize and interact with them. Experimenting with header additions, removals, and edits in Inspector helps grasp how the corresponding raw version changes in response. Moving on to answer the question below. Which section in the Inspector is specific to POST requests, and that is the body parameters. Furthermore, now we're on task 4, message analyze toolbar. Repeater provides us with various requests and response presentation options, ranging from hexadecimal output to a fully rendered page. To explore the options, we can refer to the section located above the response box, where the following four views buttons are available. So we have these so far. We are presented with the following display choices. Pretty. This is the default option, which takes the raw responses and applies slight formatting enhancements to improve readability. Raw. This option displays the unmodified response directly received from the server without any additional formatting. Hex. By selecting this view, we can examine the response in a byte level representation, which is particularly useful when dealing with binary files. Render. The render option allows us to visualize the page as it would appear in the web browser. While not commonly utilized in a repeater, as our focus is usually on the source code, it still offers a valuable feature. Most scenarios, the pretty option is generally sufficient. However, it is beneficial to be acquainted with the usage of the other three options. Adjacent to the view buttons on the right hand side, we find the shown none printable characters button /n. This functionality enables the display of characters that may not be visible with the pretty or raw option. For example, each line in response typically ends with the characters /r/n, representing a carriage return followed by a new line. These characters play an important role in the interpretation of HTTP headers. While not mandatory for most tasks, this option can prove advantageous in certain situations. So for the answer the question below for this chapter, we have which option allows us to visualize the page as it would appear in a web browser, and that is render.